Hello, and welcome back to week 3 of the Unreal Specialization. So this is a recording of the technical part of the tutorial. We're going to be covering interfaces and interaction today. So before we get into it, I'll just go over what interfaces are and why they're so good. So in this class, we're going to make a door, a lamp, and a record player. And our player's going to cast out a ray, and when it hits something, we want to interact with it. So the way you might do this without interfaces is we'll cast out a ray, and if we hit our lamp, we'll go, okay, is the thing we hit a lamp? And then we'll go, yes, okay, we'll call the toggle lamp function. But we also want to interact with a door and a record player, so we also have to check every time we cast out a ray, did we hit the record player? If so, okay, play the play record function. Did we hit the door? Okay, if so, call the open door function. So every time we cast out to hit something, we're going to have to check for every single possible object that we could be interacting with, and we'll have to cast to all of them. So our player will need to have references to every possible object that it could ever interact with, and it'll need to know which functions it needs to call on those objects. Which is maybe all right if you've got one or two objects, but once you start adding more, now we're going to have to keep checking for every single possible interactable object. And our player class is just going to get massive. And not only that, but every time we add a new object to interact with, we've got to go back and change our player class. And this just gets really hard to deal with. And now if we remove one of these objects, now our code in the player is going to break, and it's going to get really messy and really complicated. So what we'll do instead is we'll create what's called an interface. And it's not like the UI interface, it's a programming interface. And a programming interface is just a set of names of functions without the actual implementation. So the interface will only have the name of our function interact, but it won't have any code for that function. And so what we'll do instead is we'll add this interface to our record, our lamp, and our door. And because the interface only has the name of the function, when we add it to the record player, we will define what we want that interaction function to do. So when we add it, we'll add the interaction interface to our record player, and we'll make the function play a record. And on our lamp, we'll make the function toggle the lamp. And on our door, we'll make the function toggle the door. And the good thing about this is that it means that all our player has to do is it just has to cast out and say, does this have the interaction interface? And if it does, call the interact function. And the player doesn't need to know anything about what it's hitting or what it needs to do. And we can just keep that just on these objects. And the great thing about that is that we can keep adding as many things as we want, and our player class stays nice and simple. All it has to do is cast out and check if the thing it's hit, it has the interaction interface. And if so, call the interact function. So we could add NPCs and all sorts of different objects into our environment. And our player class won't need to have hard references to any of them. And we can just keep adding and removing as many as we want, and we won't have to go back in every time and edit our player class. So that's why interfaces are just so great. And for this specific use case, you always want to use an interface. So that's just a little overview of what interfaces are. But yeah, you'll get a better understanding of it once we get into the engine and start making one. So let's do that. Okay, so I've opened up the template project for this week. So this just has a little room, and we already have this lamp blueprint that we made last week, which we can turn on or off. The lamp blueprint still has this toggle flashing function that we made last week. So we don't need that today because we're just going to be toggling it on and off. So we can just delete this set timer by event in the lamp blueprint. So first we'll create our interaction interface. So we'll go to our content drawer and we'll create a new folder called interfaces. And we'll right click and we'll go up here to blueprint and find blueprint interface. And the naming conventions for these is capital BPI for blueprint interface, underscore whatever you want to name your interface. So we're going to call this BPI underscore interact. And Control S to save that. And we'll open it up and you'll see that you can't edit any of the definitions of your functions. You can't add any code in here. And that's because the interface just has the names of the functions and the implementation is defined in whatever you add it to. So every one of the objects that we add this interaction interface to will have a different implementation of the interaction function. So we'll just go up to this default function that's in here and we'll rename it to interact. And we'll compile and save. And that's all we need to do in here. So to get this to work, we'll go over to our LAMP blueprint and we'll go to the class settings. And in interfaces, you'll find here implemented interfaces. So we're just going to click this little add drop down and we'll search for the one we just made. So we'll search for BPI underscore interact and click on that and compile and save. And now in your event graph of your blueprint, under this interfaces tab, you'll see this new interact function. And if we double click on this, it'll add that to our event graph. And now we can define what we want to happen when this interact function is called. And we just want to toggle the lamp. And we've already got this toggle lamp event from last week. So we can just drag off this pin and search for toggle lamp. And when we call the interact function on the lamp, we're going to toggle it. And that's all we need to do in the lamp. So we'll compile and save. So now let's get this working with our player character. So before we can get interaction working with our player character, we'll need to define what button we want to trigger the interaction function. So we'll go to our input folder and the actions folder, and we'll add a new action and create a new input action. We'll call this IA underscore interact and Control S to save. And we can leave this as digital bool because this is just a on or off interaction. And then in our mapping context, we will add a new mapping and we'll find our new interact action. And I'm going to map this to the mouse left mouse button. And I'll save that. Okay, so let's open up our player. So this player already has that mapping context added, so we should have our input action in here now. So if we search for IA underscore interact, we'll find our input action. And we're going to need this variable in a second. We'll need a variable to store how far away objects need to be for us to be able to interact with them. So we'll create a new variable and we'll call it interaction range. And we'll make this of type float. So we'll click this little arrow here because we don't want to use triggered. If we use triggered, then it will keep triggering this as we hold down whatever key we've assigned. So if you keep holding down your left mouse button, it'll keep triggering the interaction over and over and over again. So we just want started, which will only happen once the first time we press the button, and it won't be reset again until we let go. So off of started, we're going to do a sphere trace by channel. And we'll get our camera. And off of here, we're going to get world location. And we'll use that as the start of our sphere trace. And then we'll get the forward vector. And we'll search for a multiply node. And we'll multiply this forward vector by our interaction range. And then we need to add this to our camera's world location. And that will be the end of our sphere trace. Now, out of the hit, if we right click on this, we can go split struct pin to get all the different information of what we've hit. Oh, by the way, we want to set this radius to something reasonable like 25 or 5 and compile and save. So this is going to give us all the information about what we've hit. So what we want to do is we want to get what we've hit and we want to check if it's got the interaction interface. So we'll get this actor and we'll let go and we'll search for does implement interface. And we'll check for our interface BPI interact. And then we'll hold down B and click to create a branch. And if it does, then we want to get this actor that we've hit and we want to call our interact function. And you can see here under this BPI interact interface, there's the interact function that we made. And we'll connect that and compile and save. And that's it. That's all we need to do in our player. And now anything that we add the interaction interface to, when we press our interact button and we hit it, it'll call that interact function. So we can add that interface to whatever we want. So let's test it on our lamp now. And I'll click. And nothing's happening. Why? Ah, our interaction range is 0. That's probably not going to be enough, so let's set it to something like 300. Cool. So now when we click, our lamp is going to toggle on and off. So this is cool, but it'd probably be good to have some kind of visual indicator when something's interactable or not. So let's add an interaction dot to the screen. So we'll create a new folder called UI. And in the assets for this week, there is this interact dot texture that I made. So we will just drag that in to import it and save. And now anytime in Unreal when you're making interface elements, you're going to use a widget blueprint. So we'll right click and go user interface widget blueprint. And we can just make this just a regular user widget. And we'll call it WBP underscore interact dot. And Control S to save that. So here's our widget. But we can't add anything to it yet because it doesn't have a canvas. And the canvas is kind of like the base that represents the screen that you can start adding stuff to. So we'll go to our palette and we'll search for canvas. And then we just drag it from here onto this top element and let go. And now we have a canvas. We can start adding stuff to the screen. So the next thing we'll need is an image. And you can find it here in the common tabs, or you can just search for it. So we'll grab an image and we'll drag that onto our canvas and compile and save. So we'll need to set a few settings on this image. So over here in appearance, if you press the little arrow next to brush, we can set what image it is. So we could either search for our image here, search for the dot, or we can just drag it straight from the content browser into the slot there and compile and save. And the next thing is we want this to be, right now this weird flower thing shows that it's anchored to the top left corner of the screen. So no matter how big your screen size is, it will always be in the top left corner. We want our interact dot to be anchored to the middle of the screen. So if we click on our image and go to the details panel and click this drop down on anchors, you can see all the different options for anchoring. And we want to select this one here for the middle. It'll still be in the top, and that's because Unreal offsets the position once you change the anchor, but now all the position will be relative to the middle of the screen. So we'll set these positions to 0, and we'll change the alignment, which works just like text alignment, to 0.5 and 0.5 so that it's always center aligned on this dot. And then the last thing is we'll adjust the size in the X to be 30 so that it's not squashed anymore. And there we go. This is our interact dot widget. So we're done here. We can compile and save. And now over here in our player blueprint, before we can add this interact dot to the screen, we need to create it. So I'm going to make a little sequence node here. And then after I'm done adding this mapping context, it's going to run this pin. So we'll come up here and we'll do create widget. And for the class, we want to select our wvp underscore interact dot that we just made and compile and save. So now this has created it. It won't be added to the screen or anything yet. It'll just exist in the game. So so that we can add it and take it away from the screen, we're going to need to keep track of this widget with a variable. And the easiest way to do this is to right-click on this blue pin and select Promote to Variable. And that'll automatically create a new variable of the right type. And we can just name this what we want. So we'll name it our interact.widget and compile and save. Okay, sweet. So now we've got our interact.widget. And we want it to be on the screen when what's in front of us is interactable and off the screen when it's not interactable. And so that means we're going to need to change our interact code here a little bit because we're going to need to know every frame whether the thing in front of us is interactable or not. So we'll need to move this check to the event tick. So we'll right click and search for the event tick, which is called every frame. And we can alt click on this to disconnect it. And let's plug this in. So now every frame we're checking, does the thing in front of us implement the interface? And if it does, we'll do something. But we don't want to be calling interact because we don't want to automatically interact with stuff. We only want to do that when we click our interact button. Compile and save. Instead, we're going to store the thing in a variable if it's interactable. So we'll right click on our out hit actor and select promote to variable. And we'll call this interact actor and compile and save. And so if it does implement the interface, then we want to set this interact actor variable to whatever we just hit. So we'll plug that into true. And if it doesn't implement the interface, if this is false, then we want to set this interact actor to nothing. So we'll drag it in and we'll set it. And we'll just leave this blank so that it'll clear the variable. It'll give it no value. And we'll compile and save. And now with our interact.widget, we'll get this variable, which has our interact.widget, and we'll drag off of this blue pin and we'll search for add to viewport. And we'll connect that if it does implement the interface. And if it doesn't, then we'll drag off here and we'll search for remove from parent, which will just remove it from the viewport. And compile and save. So this is cool. Now if we come near something interactable, this little dot will show up. But if we click now, we won't be able to interact anymore. And that's because we've killed our interact function. So we'll have to hook that up again now in our player. So we'll go to player. And we'll find IA underscore interact. And when we press our interact button, what we want to do is we want to get this interact active variable. And we want to search for the isValid node. And we want this one with the question mark. And this is just going to tell us, does this have a value or not? So if we've set this to nothing over here, then it will have no value, and it'll run this is not valid code. And if we have set it to a variable, then it'll be running is valid. And the way we've set it up over here is that it's only going to have a value if it's interactable. So that means that we only want to interact with it if it's valid. So we're going to drag off here, and we'll search for interact, and we can find our interact function again. And we'll just plug this into is valid. And we don't want to do anything with it if it's not valid. And remember, we've connected this to started, not triggered. All right. And we'll compile and save that. And now our interaction's working again. And we have this handy dot on the screen, so we know when something's interactable or not. I'm just going to do a little optimization to this because this will be adding it to the viewport every frame, but we only need to add it to the viewport if it's not there already. So we only need to really do this once every time we get a new actor that's interactable. So I'm going to right click and search for a do once node and plug that in there. And then I'll put a sequence here so that if we get an actor that's not interactable, we'll reset this do once and plug that in and compile and save. Cool, so now we have this interactable lamp. Let's make some more things to interact with. So in the assets for this week, we've got a mesh for a door and also a record player. So let's set up the door first. So under assets, we'll create a new folder for door. And bring in our door mesh. And I'm going to set this to do not create material because I want to make them myself. And import. And we'll create a new folder for textures. And I'll import the door textures. And save that. And save these as well. And we'll create a new, we're not going to create a base material because in the lamp, last week, we already made this substance master material. So we can just create a new instance of this master material to set up our door because the door was also textured in substance. So we'll right click and create a material instance and call it mi underscore door. And if we open up this material instance, we can set this parent to our m underscore substance master and save that. Now remember on your occlusion roughness metallic maps from substance, you've got to uncheck sRGB, otherwise they won't be read properly. And I'll duplicate this, call it mi underscore door frame, and save that. And I'm going to assign these materials on the mesh so that I don't have to reassign them every time. Sweet. So now our mesh is all set up, and we've got our door. So let's create a blueprint for our door. So we'll right click and create a new blueprint class. This will just be an actor. We'll call it capital BP underscore door and Control S. And we'll drag in our door meshes and compile and save. Now, on these meshes, I've set the pivot point to the bottom left, so it's easier to just rotate it for our door open. But if you have a door mesh that doesn't have the pivot point on the bottom left, then you can just use a scene component, which is like the Unreal version of a Unity empty, and you can just parent your door to the scene component and rotate that instead, and that'll work just as well. So to create our door opener animation, we'll go into our event graph and we'll get our door, and we'll need to store its starting rotation. So at the beginning of the game, we're going to get the world rotation of our door and right click and promote this to a variable, and we'll call it door start rotation, and we'll connect that to begin play and compile and save. And so that this is interactable, we'll go to our class settings and we'll find implemented interfaces and we'll add our interact interface. So we'll search for BPI underscore interact, compile, save, and now we'll have this interact function. So we can double click that. And this is where interfaces are just super awesome because we can have totally different code run here than we had in our lab. So I want this to alternate, so I'll create a flip-flop node. And the flip-flop will just alternate between running A and B, and it'll start with A. So when this runs, we want to rotate our door 90 degrees to open. And we could just use a lerp, but for a bit more control, we can use a timeline. So timelines are super useful for this kind of thing in Unreal. So we'll right click and search for timeline and find add timeline. Call this door open alpha. And if we open up our timeline, it'll have nothing in it yet, but we can set the length. So we probably want to take 1 second to open. So we'll leave that at 1. And we'll add a track, and we'll add a float track. And this is just going to be a variable that animates over time how open our door is going to be. So when it's 0, our door will be closed, and when it's 1, our door will be open. So we'll call this door open alpha, and we'll add a new key, and we'll set the time for this to 0 and the value to 0, so that when it starts, our door is closed. And we'll add another key, and we'll set the time for this to 1 second, and we'll set the value of this to 1, so that when our timeline's finished, this value will be 1, and we can use this to interpolate the rotation of the door. And if we want to make this animation a little bit smoother, we can right click on this and go to auto, and that'll turn it into a Bezier curve so that it just has a little bit of easing and looks a bit more natural. So we'll compile and save that. And when this interact is called, we want to alternate between playing this or reversing it. And we'll compile and save. But this won't do anything on its own. This is just going to basically change this value from 0 to 1 over time when we press this button. So we need to use this value that is going to be between 0 and 1 to open or close our door. And the way we do that is we get our door mesh, and we'll search for set world rotation. And we want to update this world rotation every time, every frame this timeline is updating. And the rotation we want to set for this is going to be our start rotation. And we'll split it. We're going to just adjust the yaw, the up rotation. So we can leave roll and pitch the same. So we can just connect those straight in. And for the yaw, we want to interpolate between whatever rotation the door is set at when it starts and whatever rotation we want it to be when it's open. So it's going to be the start rotation minus 90 degrees. So we'll create a lerp node to linearly interpolate based on an alpha. And we'll plug our door open alpha into the lerp. And for A, we're going to have our start rotation. And for B, we're going to get our start rotation, and we'll search for subtract. And we'll subtract 90 from it. And we'll plug that into B. And then the result of this will be our new yaw. And we can compile and save. Cool, so let's drag this in and give it a test. So you can see our interact dot's turning up because we've added the interaction interface to our door, and so our interact dot and everything is working. And if we click, now it's going to open. But we can't walk through it, and that's because when you import meshes into Unreal, it generates automatic box collision. So you can see this is the automatic collision it's generated for the door. And if we go to our door frame and go to show simple collision, this is the automatic collision it's generated for our door frame, and it's just a cube, which means that we won't be able to walk through it. So we want to adjust this collision to what we need, which is collision only on these side parts and no collision in the middle. And that you can make your own collision meshes and import them, but the easy way of doing it is just to go to collision and find this option down the bottom here, auto convex collision. And this gives you the options for creating new automatic collision. This is pretty simple, so we can probably just leave this at default settings. And there we go. Now we've just got collision on the sides, and we'll be able to walk through it. So we'll save this mesh. And now when we open our door, we can walk through it. So this is the cool thing about interfaces, is you can keep adding more objects and you don't need to ever change your player class. Your player doesn't need to know all the different things it can interact with, it just needs to know, does it have this interface? So you don't end up with all these hard references to your player and doing all these complicated checks like, is what I hit a lamp, or is what I hit a door, etc. Cool, so let's make one more. Let's make a record player. So I'll import our record player mesh. And save these. If you ever want to edit the properties of multiple assets at once, you can just right click and go bulk edit in property matrix. So I'll create two materials, record player, and our record. Sweet, so we'll create a new blueprint for our record player. This will be an actor as well. Call it BP underscore record player. And save that. And we can drag our meshes in. And before we do anything else, we'll add the interaction interface. So we'll go to our class settings, search for implemented interfaces, and search for BPI interact. And compile and save. And in our event graph, we'll add a call to our interact function. So we want this to play a song when we interact with it and stop playing it when we interact with it again. So we'll need to add a couple of components here. So we'll add an audio component. And this is going to be what plays our sound. So we'll import the song from this week. And we can just drag this from the content browser into the sound for our audio component. And we'll have to set a couple things in here. So by default, audio components will just play automatically at the start, and we don't want that, so we'll disable auto activate. And we also want this to get quieter as we move further away and louder as we come closer and sound like it's coming from the left when it's on the left and stuff like that. So we want to click override attenuation, which will enable spatial audio for our sound. And compile and save. So first we'll need a variable to keep track of whether it's playing or not. So we'll create a new variable and call it record playing. And we're going to make this a Boolean variable because we want it to be a true or a false. And what we'll do is we'll get our isRecordPlaying variable, and then we will set it to the opposite of whatever it is right now. And if we right click and search for a not Boolean, that operation will just make it whatever it isn't. So if this value is true, then it'll make it false. And if it's false, it'll make it true. So we'll set it to whatever it's not. And then we'll do a branch. And now if our record playing value is true, then we want to get our audio component. And we will search for play. And if it's false, we'll get our audio component and we'll search for stop. And compile and save. So at the start, this record playing variable will be false because we'll leave this default value at false. And then when we interact with it, it's going to invert that variable, so it's going to set it to whatever it's not, so it's going to set it to true. And then because it's true, it's going to start playing the audio. And when we click on it again, it'll change it to false and stop playing the audio. And we'll compile and save. So let's make a little table for our record player. And now if we go over to our record player and click, it'll start playing our song. And if we click again, it'll stop. Cool, so this is almost done, but it'd be even better if this record was rotating. So let's do that. So we'll open up our record player. And we want this record mesh to rotate. But the pivot point is at the bottom of this mesh, and we want it to be rotating around the center. So the way we'll do that is we'll add a scene component, which is just like an empty, and we'll call this one record pivot, and compile and save. And we will move this pivot to the center of the record. So I'm just going to go up to perspective and top view, so it's a bit easier to line up. And then front view, so I can line it up with the center of my record. So now we've got this empty right in the center of our record. And if we parent our record mesh now by dragging onto this empty to the empty, now when we move this record pivot empty, it'll rotate our record. Perfect. So we'll compile and save. And so to do this, we'll create a variable called record rotation speed. And this will be a float. And we can set the default value of this to like 90. And compile and save. And so what we want to do is every tick, we want to get our record pivot. We want to get the world rotation. We'll split this. And we want to set the world rotation. And we'll split that as well. And we're not going to touch roll and pitch. We want to just rotate yaw, same as the door. And what we want to do is every tick, we want to add our rotation speed to the yaw of our record pivot. And we'll plug that into the new yaw so that every tick it's rotating. But if we leave it like this, because this tick is called every frame, the faster your frame rate is, the faster this record's going to rotate. So if you've got like 15 frames a second, it's going to rotate really slowly. And if you've got a beast computer that's running it at 120 frames a second, then your record's going to be flying. And we don't want that. We just want it to be independent of your frame rate. And the way to do that is to multiply it by the amount of time since the last frame. So we'll multiply our rotation speed by the amount of time that's passed since the last frame. And we'll plug that in instead. And we'll compile and save that. Sweet, so this is going to rotate our record, but we only want to do this if the record's playing. So we'll drag in our record playing variable and we'll get it. And we'll hold down B and click to create a branch. And if this record is playing, then we want to rotate it. And if it's false, then we don't want to do any rotation. So we can just leave nothing here. And we'll compile and save. And there we go. Now it's playing our song, and it'll rotate the record while it's playing. So that's it for week 3. Next week we'll be covering animation. Hope you all have a great week. See you soon. Bye.